Okay, I've podcasted this, so hey everyone, thanks for joining. We'll just start in another 3 to 4 minutes. Hey guys, thanks for joining. We'll start in about 1 or 2 minutes. Meanwhile, I'm just intrigued to understand as to where all of you have joined from. Hi everyone, I'm Gyan and I'm the Leadership Fellow for the Blockchain Track at Women Who Code. And I'm joining you guys today from India. It's going to be 9 p.m. here. Feel free to just type it out in the chat box. Also, feel free to type your questions on the chat box at any point in time, and we'll try to get it all answered by the end of the session. You could also put your question at the Q&A box. Is it 9? Okay, cool. So let's start, and as and when people join, they can join us wherever we are. So I want to start. I'm going to take a couple of minutes to introduce the Women Who Code blockchain community and talk about what we do. And then I'll hand it over to Jyoti, who's our speaker for today, and she'll take over and teach us about Hyperledger. So first of all, thank you so much for joining us today. I know it's a Friday. Wherever you are, it's either Friday night, Friday afternoon, Friday evening for all of you guys. And yes, this is our own awesome party today where we are learning about Hyperledger. So yay! Um, so for those who aren't familiar with Women Who Code, Women Who Code is a global nonprofit which is dedicated to inspiring women to excel and sort of encourage them to come more into technology facing careers. That's our mission. Our vision is we envision a world where women are proportionally represented, not only as technical leaders, execs, founders, VCs, at all levels. So every day at Women Who Code, we strive to understand what are the gaps between the industry and what we do to get more women to come into technology, and of course excel as leaders, developers, engineers, whatever they would like to do. At Women Who Code, we follow a strict code of conduct. That is, we are an inclusive community, and we encourage all of our participants, all of our community, to also have an inclusive mindset. At any point in time during the webinar, before, after, or at any point in time when you have been working with Women Who Code, if you feel that something is not right, then you can fill out our incident report form at womenwhocode.com/code of conduct, and we'll definitely look into it. So Women Who Code has been working geographically so far, trying to empower women across the globe. And we got a lot of requests from women that they wanted to learn, or they wanted to focus and deep dive into certain technologies. And that's why this year we released 6 deep technical learning communities, one of which is blockchain, which is called Women Who Code Blockchain. And this webinar is a part of Women Who Code Blockchain. This is my awesome team. I am Gyan, this person right here. And I lead the community. I work with women across the globe, help them help them come on board as speakers, and also help them understand and study, get into the technology itself. How do we do that? We do tech talks, workshops, tutorials. The one today that you're attending is a tech talk. There are going to be tutorials and workshops on Hyperledger as well that are going to be happening. Live stream events that are happening across the globe. We try to live stream the events and get them to you. Technical study and project groups. So we are having a study group which is on 21 days of smart contracts. That is, we are going to write smart contracts in Solidity to get you up to speed with programming in Solidity. So events like that keep happening. We'll have panels, fireside chats, lightning talks, all of these things, networking opportunities with track topic focus members. So every speaker who we bring on is somebody who's passionate about the technology and this cause, and they offer their expertise for free to the community. And you can always reach out to them to connect with them, network with them, understand how they can help you, understand how you can work with them, etc. One of the things that I'd like to do is thank our amazing sponsors, Stellar and Hired, for sponsoring the Women Who Code blockchain track. Without them, this community would not be existing today. And all of these free events that the community is able to do throughout the year, thanks to these sponsors. One announcement that we have for our track is that we're going to have our Women Who Code Blockchain Summit, which is the first summit of the track this year. And it's going to happen on the 5th of December at New York. The CFPs are open, so feel free to submit your proposal. We'll definitely love to get more and more women and men submit their proposal topics, and we'd love for you to come and present at the summit. So you can take back something from this workshop and maybe try and create a use case and create a CFP out of that. Well, as all the communities, like all the communities, we are also prevalent on social media. Our core community is womenwhocode.com/blockchain, where if you go, you can see all the events. You can register for all the events. All the events are open to all, and they are free of cost. You can follow us on www.code.blockchain on Instagram. And if you find something cool about blockchain, feel free to tag us on Twitter or Instagram. And we have a lot of Slack events happening. We have something called Tuesdays with Tech, wherein every Tuesday we try to explore one topic in blockchain. Once you join our Slack, you'll be able to explore those things as well. And we have coding resources, reading material, everything available on womenwhocode.com/resources. So this is my last slide. And now I'm going to hand it over to Jyoti. Jyoti, can you please introduce yourself and maybe talk a little bit about what you do, and then take over the Hyperledger bandwagon from there?
Sounds good. Can you hear me?
Yes, I can hear you.
Great. Thank you so much, Nan. There was a lot of information on women who code. All the attendees, please take advantage of this organization. God knows we need a lot more women representation within the industry, and a lot of companies and corporates are getting, excuse me, getting towards encouraging women to attend with more programs or introductory offers and so on. And everything you have said up until now is so much information and so much of valuable knowledge that's been given out to women to encourage them to come on board into the technology industry. Well, having said that, this is me, Jyoti Punapalli. I am the founder of Blockchain Solutions. We are a women-owned small business. We are certified women-owned small business by WeBank. We're based in Dallas, Texas, in USA. I have been in the industry for about 21 years, working in IT and doing many things. I started my career as a developer, hands-on coding and so on, and then moved up the ladder to do architecture in corporate collaboration portals. And the natural progression seemed to be cross-corporate collaboration portals, which is where blockchain comes in. And that is how we branched out into providing consulting services within this space. Now, let me just make sure, is everybody able to see my screen?
No, Jyoti, I'm not able to see your screen yet.
Okay, let me see. Okay.
Do you see the share option? I think.
Yes. I'm getting there. Trying to.
Yes.
How are you able to see my screen?
Yes.
Good. Alrighty. So here we are in the. Okay, that's my first slide. Okay. So I've already said we are the founder for the, I'm the founder for the Blockchain Solutions. We are 100% women-owned small business, and we consult in blockchain-centric applications and enterprise-centric business projects and so on. Now, a quick agenda on this session is I'm going to start off with defining blockchain. We all have heard of blockchain, but I want to give you my personal experience, how I have learned what blockchain is. Next is I want to move on to, obviously, this is introduction to Hyperledger. So I will walk you through a few slides pertaining to Hyperledger project and the frameworks and tools and so on. And then we will talk about the popular use cases, which is what will actually allow you to tie the real life applications into the technology and give you a better understanding of how this technology can be utilized around us. And then we'll open up for Q&A if you have any questions, and I'm happy to take them to answer as best as I can. Alrighty, now let's move on to the first topic on the agenda, blockchain. So what is blockchain and how did it come about? If you look at the name, it's a chain of blocks, right? A block in a blockchain is a collection of data. Now, what is this data? The data, how is this added to the block? What are the different attributes of that block? So a data added to the block in the blockchain is connected to other blocks in chronological order, creating it in the chain. And anyways, the first block in the chain is always called Genesis block. Now, some of the key attributes of blockchain are, you'll see in your experience as you learn further and further about it, that one of the key attributes of this technology is peer-to-peer, distributed, cryptographically secured, append only or add only, and consensus. Now you might think, what is peer-to-peer? You know, peer-to-peer means a friend to friend, means a node to node, which means that there is no central authority that controls or manipulates the information. All the participants are able to talk to each other directly, and this allows for data exchange to be made more directly with the third party involvement. Now they're distributed in nature. I'll come to it in the next slide. I want to leave this attribute of it to explain more in detail what distributed means. Cryptographically secured. How are we able to talk to each other, especially to partners that we don't trust, and still be able to trade with them? Today, in today's scenario, that doesn't happen, right? For example, if you take supply chain, I can only trade with somebody I have a contract with, or I know who that person is and I trust that person, so I'm able to exchange the goods with that person or trade with that person. But if I am wanting to trade with a third party that I don't trust, then how do I do it? You know, what is the guarantee that this person could be trusted? Well, the technology gives you that trust. The reason it does is it's cryptographically secure. Every transaction, every line item added to the ledger is cryptographically secured using hashing mechanisms that prove to you that the ledger is tamper-proof and it's immutable. The next key attribute is add only, append only, which means that anything that goes in the ledger is either appended or edited, but it cannot be deleted. So any transaction, whether be it false or true or whatever, it just, once it enters the ledger, it stays in the ledger. It's practically immutable. And the last, but the most important core component of any blockchain technology, be it Hyperledger, Ethereum, any technology, is consensus. I'll tell you why. Because this is the critical aspect of blockchain that allows us to have a say whether the transaction is valid or not, and then add it to the ledger. Without consensus means without all of us coming together or on deciding factor of a transaction being valid or not valid, it cannot be arrived at without a central, not a central, without a distributed authority that is in control of updating. So I actually have a slide further down the line which has more detail on consensus. I'm happy to talk about it more then. But let's start about, okay, we have talked about what are the key contributing factors for blockchain to make that the technology of tomorrow. But how did it start about? Well, we all have heard of Bitcoin, right? Isn't that how we all heard about blockchain? Bitcoin was the first word we heard, at least for me. And then it became very interesting because now here you go, a couple of years ago, everyone was talking about this digital money or cryptocurrency called Bitcoin. It seemed very cool to know about it. But the underlying factor of Bitcoin, the reason Bitcoin exists today is the underlying technology, which is blockchain, right? Which is what makes that Bitcoin such a promising next generation of trading using cryptocurrencies in the world. Now, how did it come about? What I heard was a certain gentleman who will go down in history as Satoshi Nakamoto wrote a white paper on digital money called Bitcoin. And in his definition, Bitcoin is a peer-to-peer version of electronic cash. Well, this is another term, electronic cash, that allows payments to be sent directly from one party to another without going through a financial institution, which means that you can forget about banks, you can forget about intermediary agencies that allow you to transfer money from one country to another country or from one person to another person. The network timestamps transactions goes by hashing them into ongoing chain of hash-based proof of work, forming a record that cannot be changed without redoing the proof of work. This is what Satoshi Nakamoto wrote in his white paper. I'm reading it as is. So if you see the hash-based proof of work, again, I'll get it down to it. It's one of the consensus mechanisms largely used, but it's heavily used for Bitcoin. Okay, now, if you really go down this rabbit hole of going into the history, it's extremely interesting. We all want to know and talk about Satoshi, but he is an unknown person. He's not known to anybody. He is anonymous, but there is a white paper on his name, and he is the inventor of Bitcoin, alas, nobody knows the face of it. Anyways, if we really go, that way we'll be talking about it for like hours together, but let's move forward and address Hyperledger today. Now, okay, let's talk about how blockchain came about, the genesis of it. Now, traditionally, let's look at the database. Where all the data stored for the entire world. Databases, ledgers, this is where the core of the data information lies, right? Now, let's look at the basic ledger structures from where it all begins. There are basically three kinds. There's a centralized data structure, and there is decentralized data structure, and there is a distributed model. These are the different kinds of the models. Now, centralization and decentralization and distributed, they all refer to different levels of control on the ledger at the bottom of it, baseline, okay? Now, let's go into what centralized is. Centralized, traditional databases have central admins, which is what we all use within our companies, right? Which makes using them to house transactional data involving parties that don't trust one another, problematic and expensive. So what happens is today, if you're talking about, okay, let's say I am a retail company and I'm buying my goods from my supply chain vendor, and I have a central database where I have all the order information and all of the product information, but the product is coming from my vendor. So when I'm purchasing it, how do I transfer the data? I have a database where it says, where I have my records of information, and my vendor will have his own database where he has his record of information. So what does it do? We have duplicate information or duplicate data. And if any of one of our resources makes a mistake or has a malicious intent to alter the data, what does it resolve? It results in expensive and time-consuming disputes over what the actual state of the truth is. What comes in here? Legal, right? Legal companies have to battle and resolve these issues pertaining to, it could be various mistakes, right? They can come from, folks as simple as a human error, for disputes, or sometimes as big as contractual errors. So that's centralized. That is the traditional mechanism, that is the traditional ledger state, and that is the world we have been living in up until today. Now let's talk about decentralization. In a decentralized system, there is no one single controlling entity or authority. Instead, control is shared among several independent entities, which means that if I am a member of that network, or anything, for that matter, let's say a network or ecosystem, then I own a copy of the ledger. And it's the same copy of the ledger that every one person, every single member, participant of my network is. That's called decentralization. Everyone has control, everyone keeps the control, and everyone has the same state of the database, which means that there are no disputes, which means that there is no ambiguity in terms of what version of truth you have or what version of truth I have. It is a single source of truth. Now, coming back to the third model, which is the distributed model. Now, blockchain is a distributed ledger, which simply means that the ledger is spread across the network among all peers in the network, and each peer holds a copy of the complete ledger. It's a distributed database with no single authority and no point of trust. So when you want to share a database and you don't have a lot of trust with the other people, or you don't sometimes even know who those people are who might use it, a blockchain technology becomes extremely useful. So one of the key questions you want to ask yourself for any new project or new initiative at the workplaces you're working on is the first thing: who am I transacting with? Who is my partner in the network? Do I trust my partner? Do I know who those partners are? But trade becomes imminent, right? In today's world, we still want to be able to trade. Up until now, you can't trade with someone you don't know or you don't trust. But blockchain makes that happen. Blockchain enables you to, trust someone that you don't know or trade with someone that you don't know, because the underlying technology has features such as cryptographically storing the cryptographically storing the transaction, so there are no disputes and it's all immutable, which means that nobody can come back and alter the state of the ledger. Let's move to the next one. This is blockchain categories. Now, previously, so I've been in this business for quite some time. So when the markets and the industry was still figuring out their footsteps, initially blockchain categories were defined to be more public-private, consortium-based, hybrid in some cases, but not as much. Anyways, but what it has actually trickled down to and being redefined is that blockchain categories in today's world are basically two types, period. One is permissionless and the second is permissionless. What is permissionless? Permissionless basically means that anyone can read the chain. Anyone can participate in the network. Anyone can, of course, you have to have the resources, right? You have to have a node, you have to have computing power, you have to be, able to, of course, electricity, the basic necessities that you would want to stand up a node, run it, and join it to the network. But anyone can make legitimate changes. Anyone can write a new block into the chain, and then the rest of the network doesn't need to know who you are. Now, one of the most popular examples of it is Bitcoin, or you'll hear me going back to Bitcoin quite a bit because this is still introductory session. There are quite a few other cryptocurrencies or other classifications coming up, but let's keep to Bitcoin for now. Okay, so Bitcoin by far is the most popular example of a successful public blockchain network. The reason I say successful is it's trading at 10,000 some odd dollars, and no other cryptocurrency is able to come as close to as the trading value of Bitcoin yet. It is totally decentralized. It's also described as sensor-proof blockchain. Bitcoin and other cryptocurrencies, well, like Ethereum is quite popular too. On the contrary, what I would say is Ethereum could be secured by requiring their entities, sometimes, could be permission, like you can require for their entities to authorize themselves to the network. But the common consensus between these two is proof of work. Due to the nature of how public blockchain works, they would require that the computer resources have intensive mining process to add blocks cryptographically. Well, I know I've tried that because I've tried mining a couple years on my computer, and I almost killed my baby because it took so much computing power to mine one block that I had to quit midway. I just didn't have enough computing power. today, most of that happens, from what I hear, in Siberia and China. Well, where it's almost the electricity mining rates are way below than other countries. I think that makes it more plausible for them to run mining from those countries. Now, the great advantage to an open, permissionless, or public blockchain network is that guarding against bad actors is not required and no access control is needed. This means that applications can be added to the network without the approval or the trust of others, but there's no central authority, like I said, and you can use a transport layer, and it's the widest description of the public blockchain. If you're using a transactions layer and networking with the network, well, that's one category, which is permissionless. Now, moving to the next category of blockchain, that is permissioned. And like the term says, essentially they are closed ecosystems where members are invited to join and keep a record of the ledger. Now, the most commonly known permissioned blockchains are Hyperledger, RC, Corda, and so on. Permissioned blockchains use an access control layer to govern who has access to the network, which means that you could join as a member of your company, or you can identify yourself as a certain someone before you are able to join the network. So in direct contrast to the permissionless blockchain networks, there are validators on private blockchain networks who will vet the every participating participant on the network, either periodically or every time they come on the network to transact. So there is no anonymity in permissioned blockchain. There is no anonymity with respect of anything, whether it is a person coming on the network, whether it is a smart contract that's running to determine the legalities of a particular any conditions. There is no unknown node, because every node has to be identified, either pertaining to a particular company or a particular user, with KYC, strict KYC, and they also rely on something called consensus, of course, right? Because like I said, it's the core of blockchain, which basically does two things. It's ensuring that the next block in the blockchain is one and only version of the truth, and it keeps powerful adversaries from derailing from the system and successfully having to fork the chain. Now, consensus protocol comprises of three basic steps. Now, please bear that consensus protocols can have varied number of steps to achieve its consensus, means to its finality. How does a transaction reach its finality, and how is it determined that it is the perfect version of single source of truth? What I'm going to list here or say is Hyperledger centric. So please bear that these are not the same steps of consensus that other technologies will necessarily have to follow. But consensus protocol for Hyperledger basically follows three steps, which is the endorsement, ordering, and validation. Every node within your network assumes a role, and that role, he behaves or she behaves or the node behaves in contention with that role, and then they will determine what they have to do with the particular transaction. Now, Hyperledger goes through, the first step is endorsement. It determines whether to accept or reject a transaction. Ordering, which means all the transactions are sent to one node, and that one node says, okay, if I have 100 endorsement nodes within my network, and if I can get 99 of them to endorse a particular transaction, I think I know my 99 nodes are telling me the truth, which means that finally it can reach validation. And the ordering node is the one that determines that factor and sends it to the validation node, which verifies the endorsement, satisfies the policies. Policies are driven by the smart contracts again. And then it tells the ledger that, yes, please make a copy of this transaction within each node and make sure all the ledgers are in the same state. Now, you could also call permissioned networks as consortiums, because if it is a team of companies that come together to form an ecosystem, then it does become a consortium, right? Yeah. So sometimes permissioned blockchains are also go by the name as consortium blockchains or hybrid. All right. Now we are going to move on to Hyperledger. So some of the key so when you say Hyperledger, right, it's a pretty huge project. So what I want to address within the limited time we have today is how Hyperledger, what is it, from a project perspective, how it came about and how it came into existence, who are its major supporters, and what are the key differentiating factors? How does it differentiate itself from other blockchain platforms? And what are the different use cases that are in production and running applications, and some of the key benefits of using enterprise blockchain. Now, what we are doing is we are clearly deviating away from cryptocurrency. There are two different types of blockchains. Blockchains that enable payment structures, which is whether it is token concept or cryptocurrency, and blockchains that are strictly enterprise-centric, that are utilized for solving enterprise problems, which could be collaboration related or cross corporate collaboration related. Now let's look at this. This is the Hyperledger greenhouse, what I call it. The Hyperledger is actually an open source. It's an effort created to advance cross-industry blockchain technologies. It's a global collaboration that is powered and backed, powered by the Linux Foundation and backed majorly by IBM. These are the two main key investors within this open source technology, and then they formed a greenhouse. This greenhouse today comprises, they have grown, the past couple of years, they've grown tremendously, and they have been adding frameworks and tools to their greenhouse as we speak. In fact, today they are at a total of 6 frameworks and 8 tools. Each of them takes a different approach to creating business blockchain, whether it's tools or the frameworks. And the frameworks are meaningfully differentiated approaches to business, to different business blockchain frameworks. They are actually, because it's open source, they are developed by a growing consortium of communities. And like I said, it's open source. Anybody can contribute. Even you guys tomorrow can write a set of code and contribute to the Hyperledger community. And in fact, sometimes they have bug bounties too. So if you found a bug and you want to be able to contribute, sometimes they pay you for it. It serves, like I said, it's an open source. It serves as a greenhouse that brings together users, developers, vendors from many different sectors and market spaces, and it is being developed as a community. And one of the key, the most successful blockchains that I have noticed have picked any traction and momentum in the market with respect to adoption are open source blockchains. The reason they have to be open source is when it is open source, I'm able to adopt it, I'm able to consume it, and I'm able to contribute to it. What it does is it allows me to trust it a step further. And that is why Hyperledger has gained so much momentum in the market with respect to, even though it came actually after Ethereum. So all of these participants, who are the communities, they have one thing in common. All are interested in learning about and developing the enterprise blockchains, right? Because this is enterprise-centric. Now, while blockchain is a powerful technology, it's not one size fits all. So the next question you want to ask yourself when you have a project is, like I said, when we talked about what is blockchain, you want to ask, why should this project, if you have to ask yourself the question, should this project be in blockchain, then the first question you want to ask is, am I trading with somebody I don't know or I don't trust? The second question you want to ask is, what kind of a blockchain is this? Does it need permissions for everybody? Do I need to know whom I'm going to be transacting with? Or I don't know who it is, and it can be permissionless. So any technology, even within the blockchain, there's no one size that fits all. Hyperledger fits some needs. Ethereum will fit some needs. There's a varied of other blockchain technologies like R3 will fit some needs. So there is no one size fits all technology today. Every enterprise needs special features and special modifications to help blockchain achieve its intended purpose. So different organizations have, different needs and different project requirements. But Hyperledger provides like the greenhouse structure that can incubate new ideas, support. So if you have new ideas that can enhance any of the frameworks or the tools, I'm going to say, please contribute. And it supports different varieties, and different developer communities too. They have different chapters, just like Women Who Code. Collaboration is better in open source technologies. It helps you to avoid duplicate efforts, so it can be adopted globally. It also includes a number of modules within the tools that are typically built with one framework in mind or others, but they can be expanded and ported. And the future of this ecosystem is that, like I said, no one blockchain platform fits all, one size fits all method. There may be companies that are actually hosting different blockchain technologies and still want to be able to transact with one another. So the future may be that these frameworks and tools will enable you to transact with a completely different network built on a different technology. It would not matter. That is when the actual ecosystems will flourish in the market. And I think Hyperledger's initiatives, and in fact, the roadmap and some of the directions that they have taken shows that they are moving towards more interoperable ecosystems. Like I will speak further to that note when I speak about the tools and the framework. All right, now let's move on to the frameworks. So there are 6 frameworks today, but out of those 6 frameworks, 3 of them are in incubation status and 3 of them are in active status. I will tell you why incubation status versus active status matters. Active status is when you know that you can deploy the framework in a production environment. Incubation status means that these frameworks are being actively built and actively composed and actively being put together, and they can take, even incubation active projects also can take contributions for next versions, iterative versions of it, but some of these are in incubation and you know what is possible using those frameworks. Now, I'll read a little bit into each of these frameworks just to give you an introduction, but I welcome you all to go to the hyperledger.org website and read through the white papers of each of these frameworks. And again, once you start digging, there is so much information, so much to learn in each of these frameworks. It's unbelievable. Sometimes I've noticed that consultants become more knowledgeable in one framework, and then that's it. You are a special skilled person for one framework. That's about it. So let's start with the Sawtooth. Sawtooth is a modular platform for building, deploying, and running distributed ledgers, like typical to blockchain. And it includes a novel consensus algorithm called POET, which is the proof of elapsed time, which targets a large distributed validator population with some minimal resource consumption. So that's catering to one section of the market. The next one is Roha. It's called, even though it's iRoha, it's called Roha. I don't know why. Hyperledger Roha is an, again, modular distributed blockchain platform with its own unique consensus and ordering service algorithms. It's role-based, it's rich in permissions model, and it's a multi-signature support. Multi-signature support means that you can have different kinds of PKI cryptographies enabled on that framework. Hyperledger Fabric. Now, you would have heard Fabric quite a bit. It is the most popular and the most successful framework which has gained a lot of importance in the market. In fact, you'll hear that IBM Cloud is also running Hyperledger Fabric, and some of its key production solutions are running on that framework. It is intended as a foundation for developing applications or solutions in a modular architecture. This is the key benefit. Like, no matter how many times you tell this to yourself, it'll still be the great feature of the Fabric is that it's two things. It's modular in nature and it's plug and play. It allows its components, such as consensus, membership services, to be plug and play. And it is active, and the iterative versions are coming up so fast. I'll read to this one more slide because it does deserve a slide by itself. Burrow is a permissionable smart contract machine. It's the first of its kind since it was released in 2014. It provides a modular client with a permissioned smart contract interpreter built in the specification of EVM. Ethereum has a node. All of their Ethereum nodes are EVM machines, which means that there is no reason for the smart contracts to arrive at a determinism. Just latch on to these words that I have said. I can't go deeper into those words in this session, but those are some of the words, the most common words you will hear when you are validating any particular blockchain technology with respect to its its performance and its key value indicators and so on. Indy. Indy is purpose-built for decentralized identity. It provides tools, libraries, reusable components, independent digital identities. It's rooted on blockchain or other distributed ledgers. So if you want to, do public blockchain on private permission, you have to have a digital identity for a person that's universal, right? Which is where most of the companies and the countries today are scrambling about. They're scrambling about finding that one central authority that defines your identity, a digital identity especially, which you can take, and it's like one identity that you can take it, whether you take it to the bank or whether you take it to your passport office or whether you take it to your local commission office or so, anywhere, your schools, colleges, universities, that identity is the true identity of yours. Like today, we don't have any one single, especially in a digital format, right? We don't have any one single identity. Like in some places, I have to take my passport, which proves my citizenship. It proves my age and my, my picture, what I look like, my background, and so on. Authenticated on. In some cases, it's your driver's license. Some cases where you have to take your electricity bill, or in some countries, you have to take the local identification cards. But what this technology or this, the true value potential is that if you have a single digital identity, then it enables, or it makes it a lot more easier for people to transact using that one identity instead of 10 different identities. Fabric, like I said, it is the most popular and the most adopted frameworks because of its being modular in nature and being able to plug and play. I have personally worked in quite a few projects on Fabric, and I have seen the beauty of this building this network is that I can join the nodes, I can remove the nodes, I can enhance it, I can expand it, I can shrink it, whichever way I can. And you will see that the versions are being released at a pretty aggressively 3-month time span, sometimes to 6 months time span. Today, they are at a version 1.4.1 LTS. That's the current version of Fabric that's being used. It's almost quarterly to 6 month releases. It is being developed and contributed by over 300 developers, 45 companies, and hundreds of individuals, and over 9,000 chain sets. That's enormous, enormous. All right, let's move on to the tools. Like I said, the Hyperledger project is comprised of 6 frameworks and 8 tools. So let's look into what each individual tool does or what it arrives at. let me start with Composer because that was the most long-standing tool for Hyperledger. It was built to enable the, to accelerate the standing up of the blockchain, the business blockchain network, accelerating the development using smart contracts and deployment across distributed ledgers and so on. Celo aims to bring the on-demand as a service deployment model to blockchain ecosystem. It reduces the effort for creating, managing, terminating blockchains. Caliper is a blockchain benchmark tool, which allows users to measure the performance of a specific blockchain implementation with a set of predefined use cases. Explorer, this is my personal favorite. The reason it is my personal favorite is it actually gives me a view to invoke, deploy, and query on blocks. It's like a dashboard of my ledger. So all of the databases that are used, so the Hyperledger goes with either StateDB or ChainDB. That's on-chain, ledger technology. And if you have worked in either of these technologies, you will know very quickly that you can only paginate maybe see 10 records at a time. Even that you have to go onto the console. But what Explorer gives you is like a dashboard view, or that you can you can query the blocks and the transactions and all of the associated data, which means that any read set and any write set that you have on any one single transaction, you'll be able to go in and look at the information. And I'm sure this is going to be the huge favorite for the audits too. Quilt. Now this is very, very promising, and this is something that you all should be looking into. Is Quilt will offer interoperability. It uses a technology called it's a protocol called Interledger. What it does is it allows for blockchain technologies, like I talked about, how to enhance the ecosystems, is that you have different blockchains transacting with each other, and you have to have, there has to be a protocol in between that allows for Ethereum to talk to Hyperledger. So Quilt is being developed for that reason. Ursa, Hyperledger Ursa is a shared cryptographic library to enable people and projects to avoid duplicating cryptographic work and hopefully increase security in the process. These libraries are opt-in repositories to use crypto in a more beneficial factor. They become sub-projects to your main projects, and they will, they will help towards cohesive implementations of cryptographic nodes. Aries is more recently added, which is why it's at the bottom of my list. It provides a shared, reusable, interoperable toolkit designed for initiative, focused on creating, transmitting, and storing verifiable data. It's pretty big. I haven't really had a chance to read deep into it because it's been recently added. Actually, I think it includes a shared cryptographic wallet for blockchain client. So they are moving towards payment systems. Up until now, Hyperledger didn't have any payment system. It looks like they're moving towards it. Now the last one is Transact. It represents a continuous evolution of Hyperledger towards greater componentization, towards responsible adoption of technologies. I think it will reduce the development effort for writing DLT software by providing standard interfaces for executing smart contracts. So looks like Transact will give you more GUI-based interfaces to execute smart contracts like build, deploy, and so on. Let's move on to the design philosophy. Okay, the Hyperledger's design philosophy is 5 key differentiating factors, right? For Hyperledger, it's modular in nature, which means it makes it easier to develop extensible frameworks with common building blocks that can be reused. It's highly secure. Security is a key consideration for distributed ledgers, especially since many use cases involve high-value transactions with large code databases and so on. It's moving towards interoperability in future to work with different blockchain and to be able to communicate and exchange data to form more complex and powerful networks. At Hyperledger, they believes the most smart contracts and applications should be portable across many different blockchain networks. So the high degree of interoperability will help meet the increased adoption. And I completely agree with that. They're cryptocurrency agnostic, which means that they don't have any cryptocurrency or any payment mechanisms today. And they're also agnostic of altcoins, but they are, I think, allowing you to develop some sort of a token system. That's the roadmap that they're moving towards, but currently none of the frameworks or the tools support any cryptocurrency. And the last but not the least is APIs. Isn't that what we all depend on as developers that support interoperability with other systems? They have a very well-defined set of APIs that enable clients and applications to interface with one another to enhance and support the infrastructure. Alrighty, the key factors, one of the key, most important, the core of any blockchain technology is its consensus. And a blockchain is a decentralized peer-to-peer system. Right now, what consensus means is that in simple terms, it's a dynamic way of reaching agreement in a group. And while voting, this settles for a majority rule without any thought or feeling. A consensus, on the other hand, makes sure that an agreement is reached which could benefit the entire group. It means it's agreement seeking, it's collaborative in nature, it's cooperative, and it's egalitarian, and it's inclusive. Every participant within the consensus network gets to say yay or nay towards submitting a transaction to the ledger. Fabric follows Kafka and Solo. Please know that Solo is only for development purposes. Kafka is more production use. Solo doesn't scale for production grade projects. Hyperledger Indy uses RBFT. Roha uses Sumeragi, and Hyperledger Sawtooth uses Poet. Why are these important? Because they all take different approaches towards arriving at consensus. But at the core, consensus means agreement. Let's go into the use cases. Now I'll have to maybe go through this a little bit more faster because I believe I'm running out of time now. There are three productionalized Hyperledger use cases. One is Everledger. They have gained popularity pretty quick, and they've become very known in the industry. They started off with diamond supply chain. Diamonds are high value goods, and obviously it does matter whether when you're trading with diamonds, you know that it is being cryptographically stored and traded, so you know exactly whether the diamond you paid for is a diamond that you're receiving. In a nutshell, it enables the occurrence it deters the occurrence of fraud, theft, trafficking in the black market, which is huge, right? Which is a huge problem for diamond supply chain. It assists in the identification and reduction of synthetic stones, increase the speed of transparency for cross-border transactions, especially insurance companies, banks, claimants. They can all be part of the network and actually have clear transparency and visibility into each of the movement of the project, the diamonds. The IBM Sutra. This again is quite popular in the United States. It is in production since September of last year. What Walmart wanted to do was, whenever there was an FDA recall of lettuce or the greens, which was a huge concern, that it took them days to sometimes find the origin of the farm where the problem occurred. So they had to throw away everything from every store whenever there was a recall issued by an FDA, and it took them, so because they were not able to find out where the origination occurred, which farm the contamination occurred, they threw everything out, which was the millions of dollars of losses for the food industry. So what Walmart started with this initiative in collaboration with IBM was to be able to identify whenever there was a recall and know which farm the contamination came from under 2.2 seconds in comparison to days. What this allows is that all the lettuce and all the food products wouldn't have to be thrown out, except you can just do a targeted recall. So just farm to whichever market that farm catered to, only those products could be recalled. But this is an open, not an open, I would say, it is a collaborative consortium sort of network. It has a lot of other retailers such as Kroger, Dell Farms, and so on. They have all hopped on the IBM Sutra to share the network. And IBM Sutra, this is the trade lens. This is this is obvious. Shipping industry had nothing to tell them. If you put something in in a container in a ship, it took 1 month for the ship to arrive from one coast to other coast. You had no insight into where the container was and where the goods were. This is what TradeLens does. IBM Mercer gives you a full transparency into the movement of your shipment, so you know exactly where your ship is, where your containers are, and how long it's going to take for it to arrive, and so on. Hyperledger momentum. Okay, so here it all shows, right, what they have done. The production releases, 12 projects, 11.3 million lines of code, and they have 45 plus K plus Twitter followers. They have 750 plus contributors. They have 270 plus members. Members have to pay a certain amount to gain membership within the Hyperledger project, and 50 plus are in China. That's interesting. And I would have liked for us to walk through the Hyperledger versus Ethereum versus the R3 Corda, some of the key differentiating factors, so how they differ from one from the other. This is pretty, these three technologies are, the reason I put them together in one slide is that they are more enterprise centric or enterprise driven. So it gives you a key differentiating factors between all three of them. They have a description of the plot. It's a Ethereum is generic. Hyperledger is more modular. R3 is a specialized distributed ledger. Governance is driven by Linux Foundation for Hyperledger, whereas it is Ethereum developers for Ethereum. So it's more open source for Ethereum. And R3 is R3. It's a consortium based, so only the members get to govern the platform. The modes of the operation, or rather the categories, is permissionless, so it could be public or private. Hyperledger is more permission, so it has to be private. R3 is again permission and private. Consensus is Ethereum is mining based off of proof of work. They are going to be very soon moving to proof of stake consensus model, which is going to help them improve its scalability. Hyperledger is, like we all know, transactional level, it's voting mechanism, it's CDFT, for different kinds of consensus that apply to different frameworks. R3 Corda is the notary based. Smart contracts, these are some of the languages that you can develop smart contracts in. Ethereum strictly goes off of Solidity. Hyperledger, you could do Node, Java, Go. R3 is more Java, Kotlin based. And currencies is Ether for Ethereum. You can also do tokens via smart contracts. Within Hyperledger, there is no currency concept. And R3, again, there is none. They're more, R3 is more financials driven, so they didn't do any tokenization or currencies as such. Some of the resources that I go to or I have used for putting this session together is out there. I highly recommend you all go to these and read some of the other informative material from these resources. And that is me saying thank you and sayonara. Thank you so much for taking the time to attend this Hyperledger session. And I'm happy to take any Q&A if there are any questions.
Thank you so much, Jyoti. This was super informative, and I think the video is also gonna help a lot of people. I may just play the recorded video as another event. I think because Hyperledger, like you said, is like super in demand, and everybody's trying to understand how blockchain can really help enterprises. And I think Hyperledger is a great Hyperledger project is a great place to start. So there are two questions. There were two questions during the talk by Deepthi. The first one is, which framework is most popular with consortiums?
Can you say that again, please?
Which framework is the most popular with consortiums?
Okay, so it depends on the use case, right? So there are different consortiums already formed, like Mobi. Mobi is for auto industry. They have formed a consortium, and they may be internally using different frameworks or different platforms altogether. So I would say frameworks and consortiums are based on the use cases. So that is how you would want to map it. And what I would ask you is rely on the categories of the blockchain technology and see which framework meets those categories uh, preferably, you know.
Cool. Thanks, Deepthi.
Mm-hmm.
Sorry, thanks, Jyoti. There's another question from Deepthi, which is, if
Mm-hmm.
there are 5 members in a consortium, would the members see what data is being exchanged between 2 members?
Okay, so I'll take this for Hyperledger because this is what we talked about, right, today. There is a concept called channels in Hyperledger Fabric. I did not get a chance to delve into it because it's fabric-centric. It's not common across all the frameworks. Now, what is the channels does is it allows you to create a private blockchain within the blockchain network. So if I have 10 participants within my network and I don't want to share all my data with all the 10 participants because I may be exchanging goods, a certain set of transactions with just B. Like, so I'm A. I want to do a transaction ledger, separate ledger with B. So I can create a channel. So A and B can go separate and form a channel. So they will still have the ledger transactions from the rest of the network, but what private transactions they do in between themselves stays in between themselves only. So yes, there is a possibility to do private channels within Hyperledger.
Okay, so there is one, so consensus is just between 2.
No, consensus is generic for whether it is one person's network or whether it is 100 people's network. Consensus has to be arrived at to determine the validity of a transaction. So if there are 2 participants within a channel and there are 10 people within my consortium, then my 2 people, you know, whoever are transacting, both of them will endorse the transaction. A will say, I agree to pay this amount to B, and the B will say that I agree to pay this amount to A, and they will both come together. Their smart contracts will execute, generate a transaction, and endorse the transaction. There is an ordering service sitting out there within your consortium, and that guy will say, oh, I have received an endorsement from A and I've received an endorsement from B. They both have the same data within the transaction. So I'm thinking this is a valid transaction, and then he will submit it back to both A and B. So you will understand this more further if, you know, in a Hyperledger Fabric deep dive session.
Yes. So I think just to add to that, there is a concept of consensus protocols, which which we will probably take up in the next session, which is going to be a deep dive on Hyperledger Fabric introduction and sort of deep dive understanding Hyperledger Fabric itself. So maybe once you understand what consensus protocols are, you will be able to also figure out how the consensus mechanism actually works in a consortium or in a group of people who decide to set up their own private blockchain. So that can probably help then.
Yes.
Jyoti, there's one more question from Neha. If we need to build a
Uh-huh.
permissionless blockchain, then which one should we choose? Ethereum or Hyperledger, and why?
Did you say permission blockchain?
Permissionless.
Permissionless.
Yeah, so
Hyperledger cannot be
Hyperledger.
permissionless. So Hyperledger, you can only do permissioned and private. which means that if you build a Hyperledger network, the network needs to know who you are. On Ethereum, on the other hand, you could do both, permission or permissionless. But if you wanted to do permissionless, there is no option of Hyperledger. You would have to do it in Ethereum.
Neha, is your question around building a permissionless or permissioned? So permissionless is more or less also known as public blockchain. So everybody has access to those blockchains, but permissioned is like a private blockchain that you would want to build. I mean, that you want to create amongst yourself. I don't know if Neha's still on the call. Neha, do you have any other questions? Okay, looks like she. No, okay, no, okay, cool. Um, I hope you guys have gotten your questions answered. If you have any more questions, you can also email us at blockchain@womenwhocode.com. And if you have anything specific that you want to ask Jyoti, then you can definitely reach out to her over LinkedIn, or her Twitter handle is at J. PONNA.
Punna.
Yeah.
Mhm.
And yeah, feel free to just tag her, shout out. You could even shout out and say if you found the webinar useful or helpful. And if you'd like to learn anything more, feel free to tweet us or like tag us in any of your tweets, Instagram or whatever. That would be great. Thank you so much, Jyoti. Thanks for doing this. You were traveling and you still took some time for our community. So we are really, really thankful to you. And this was super awesome. And any questions that come to me around permissioned or specifically Hyperledger, I will make sure to tag you or redirect the question to you so you can take it up with them.
Sounds good. Please do. And again, thank you for the opportunity. And it's my pleasure to speak for WW Code.
No problem. We are always encouraging more and more female speakers. Also, this gives our community a lot of motivation that there are a lot of successful female entrepreneurs in this field, and I'm sure everybody is going to look up to you to, get their hands dirty with blockchain and understand this technology and try to create some awesome projects in this. Thank you so much, everyone. Have a good Friday, good day, good night from wherever you have joined us. And we are going to have our next session on the 24th, which is going to be Introduction to Hyperledger Fabric. And we'll see you there. Thank you, Jyoti. Have a, yeah. Thanks,
Thank
everyone.
you.
Yeah. Bye.
Bye-bye.